When assessing a building, appearance can be misleading. A facility may look impressive on the outside, yet still be unsafe if its structure is compromised. As the saying goes, it is not the beauty of the building you should look at, it's the construction of the foundation that will stand the test of time. This lesson focuses on structural assessment from an operations and maintenance perspective. Your role is not to engineer or redesign the building, but to recognize early warning signs, document them properly, and escalate issues before safety, comfort, or operations are affected. 1. What building structure means. The building structure is the system of elements that supports the building and resists forces. These forces include the weight of occupants and equipment, environmental loads such as wind and storms, the building's own materials and contents. When the structure performs properly, the facility remains stable and safe. When it does not, problems may appear as cracks, misalignment, moisture intrusion, uneven floors, or, in extreme cases, structural failure. Many structural components are hidden from view, which makes routine observation and documentation essential. 2. Major elements of a building structure. Building structures are generally divided into 4 core areas. Foundations. Foundations are load-bearing elements located at or below ground level. They transfer the weight of the building safely into the soil or rock and help resist moisture and environmental stress. Common foundation types include deep foundations like piles or caissons, and shallow foundations such as spread footings. Substructure. The substructure includes below-grade walls and framing, typically concrete or steel. This part of the building interacts directly with soil pressure and groundwater, making it especially vulnerable to moisture-related issues. Superstructure. The superstructure is the above-grade framework. It may be constructed of reinforced concrete, steel beams and trusses, or wood in low-rise buildings. Its purpose is to transfer loads down to the foundation. Floor slabs. Floor slabs may be slab-on-grade or elevated. They directly affect occupant safety and comfort, and uneven slabs can signal structural movement or create trip hazards. 3. Why early structural assessment matters. Structural problems often begin small and unnoticed, then worsen over time. Early detection allows repairs to be made before costs and risks increase. While detailed structural audits require specialists, routine assessments by facility staff are still extremely valuable when they focus on consistent observation, accurate documentation, trend tracking over time. Structural assessments should also be considered as part of a broader facility strategy, including sustainability, safety, quality, and long-term performance. 4. Common structural warning signs. Structural deficiencies vary widely, but several warning signs appear frequently across facilities. These include cracks in interior or exterior walls, cracks in exposed concrete near the base of the building, arching or uneven floors, diagonal cracks following mortar joints, separation around windows and doors, slabs that have shifted or displaced at joints, standing water near the building after rainfall, moisture stains, dampness or active leaks, nail or screw heads pushing out of partitions, floor cracks, raised ridges, or tile tenting. Not all cracks are dangerous. Some are intentional, such as expansion joints designed to allow movement. Cracks become concerning when they widen over time, create uneven surfaces, appear alongside binding doors, water intrusion, or floor movement. 5. What to look for on foundations. Foundations support the building and help control moisture and environmental stresses. A foundation system may include foundation walls and footings, drain tiles and gravel fill, reinforcing steel, vapor barriers and waterproof membranes, backfill and drainage materials. Non-specialists can often spot early signs of foundation problems, such as cracks near doors or windows, openings that stick or no longer align. If you observe ongoing movement, worsening cracks, or persistent water issues, it is time to involve a qualified consultant or specialist contractor. 6. Practical prevention measures. Facility managers can reduce foundation-related risks through basic preventive actions, including ensuring soil slopes away from the building, directing roof runoff away using downspouts and extensions, avoiding planting trees close to foundations where roots and soil drying may cause movement. These simple measures can significantly extend structural life. 7. Health, safety, and operational impacts. Structural deficiencies directly affect occupant health and safety. Potential impacts include mold growth and reduced indoor air quality from moisture, loss of load-bearing capacity due to deterioration, trip and fall hazards from uneven floors and stairs, energy loss and security risks from poorly fitting doors and windows, damage to equipment and electrical systems from standing water. Structural issues should always be treated as both safety and operational concerns. 8. Natural disaster considerations. Natural hazards such as storms, floods, earthquakes, and landslides increase structural risk. While operations and maintenance teams cannot eliminate these hazards, facility managers can retain experts to evaluate vulnerabilities, improve resilience during renovations or capital improvements. Preparedness reduces long-term risk and recovery cost. Lesson takeaway. Structural assessment is about early detection, careful documentation, timely escalation. The value of the facility manager lies in recognizing warning signs early, protecting occupant safety, and reducing life cycle costs before problems escalate.